Hello, my name is Emil Harkonnen. My partners are Jack Beener and Ethan Hunt, and this is our electric house project. So here you can see that all the lights are on right now, but when I flick the master switch, which is back here, all of them turn off. When I turn it back on, all of them turn on again. Okay. I'm going to turn off all the lights now and show that each individual one works. So first of all, over here we have a doorbell that when I move this switch down, causes the doorbell to go off. When I move it back up, it turns off. Then over here we have the living room lights. They all turn on. This one's a little dimmer than the others. Here we also have the ceiling fan. I am going to turn the lights off because they do not work with the ceiling fan. Here you can see that it's moving. Okay. Moving on to the bathroom. Here we have the switch for everything in the bathroom. And finally, we move on to the living room, or the bedroom, where we have the lights for the overhead, and then we have a switch for the table light. Okay, now here you can see all the circuitry. We have two 9-volt batteries with a central point for everything where it gets its power. So both batteries come to here, and then the power all goes to there, and that's where everything branches off and goes to the lights. And then everything comes back to here, where all the power is returned to the negative terminals of the battery. Back here, you can also see that I have covered the rest of the wiring up with a piece of board. So the final house goes together like this. And all the boardings cover up all the circuitry, and they are easy to take off and put back on. So once again, here's all the lights on at the same time. And there's a master switch that turns them all on, off, and on. This is our electric house schematic. So first I would like to let you know that all the red numbers are going to be voltage, all the blue numbers are going to be resistance, and all the green numbers are going to be current. We have 3 rooms in our house. We have a big room, a bathroom, and a bedroom. The big room and the bathroom have parallel circuits as their lighting, and the bedroom has a series circuit as its lighting. So here are the measurements for the big room. The voltage throughout the parallel circuit is the same. As you can see, they're all 7.25. However, the current does change. From here, it's 4.48, and over here, it was too small to calculate. And over here, it was 0.25 amps, and over here, it was 0.11 amps. So here, as you can see, when I turn the lights on, they these two are bright and these two are dimmer. That's because these two lights receive the electricity first, and then because these resist the current of the electricity, these get less current, which causes them to be dimmer than these two. So the bathroom, as you can see, the voltage is the same as well, and the current changes after the first one. It goes lower because of the resistance of the light bulb. So here, as you can see, these two light bulbs, they are brighter than the ones up here. That's because they receive the current in a shorter distance from the switch, so there's less resistance over the wire. However, these two get they're a bit dimmer, but there's more resistance over the wire, so they are dimmer than the ones above the mirror. So this right here is the bedroom lighting. As you can see, the voltage does change over the circuit. However, the current does not change at all. This is because it is a series circuit, and those are the properties of it. So as you can see, both of the lights are the same brightness. They are dimmer than the others because of the resistance over the wire from the batteries, which are at the back corner of the bedroom over here, or big room. And because of the wire distance resistance, these glow dimmer than the others. I would just like to point out that they are all from the same manufacturer. However, these get less current because of the wire resistance over the whole entire house. Finally, I would like to show this light. This is the bedroom light. It glows a lot brighter than any of the others. This is because there's only one light in it. As you can see in the schematic over here, there is voltage that is lost between the switch and the light, and there is still quite a bit of current afterwards because there's only one light, and because it glows so bright, the reason it glows so bright is because there's only one of them, and it's receiving all of the electricity from the current. Next, I would like to move on to the doorbell. This is the doorbell schematic right here. It loses some voltage through it because this doorbell has resistance. Once again, the current is pretty high due to there only being one device using up electricity. So okay, and finally there's the fan. And as you can see in the schematic here, there's a huge voltage drop from the 9.25 that it gets at the beginning and the 2.2 after it goes through the motor. This is because the motor is very, very resistant, and it uses up so much voltage. You can also see that the current goes from 0.33 amps to 0.29 amps. This is because, once again, because of the resistance in the motor.
Electrical energy in Georgia is generated by producing 141.5 times 10 to the 9th kilowatts from coal, which makes up for 29% of the state's electricity generation, 194.9 times 10 to the 9th kilowatts from oil and gas, which makes up for 39% of the state's electricity generation, and 998.5 times 10 to the 8th kilowatts from nuclear energy, which makes up for 26% of the state's electricity generation. Coal is used in various plants around Georgia, including in New Harley, Rome, Albany, Macon, and Franklin, Georgia. Natural gas is also used in several different plants throughout Georgia. Power plants in neighboring states also generate power for Georgia. Locations in Georgia include Savannah, Port Wentworth, Smyrna, Houston, and Newnan. Nuclear power is generated in Georgia at the Hatch Nuclear Power Plant in Baxley and the Vogel Nuclear Power Plant in Waynesboro. Solar is also starting to become a more common power source for Georgia Power. Solar facilities have already been built and are being utilized at Fort Benning, at Naval Submarine Base Kings Bay, and at Fort Gordon. In addition, solar facilities are planned to be built at Fort Stewart and the Marine Corps' logistics base through Georgia Power's continuing partnership with the military to bring more renewable power to Georgia.